Lesson 4.7 teaches us about the laws of logarithms. So there's a table right here, and it is comparing our exponential laws, which we've learned in the past, to our laws of logarithms. So I'm going to try to point out some things here. Remember when we have, for the product rule, x to the a times x to the b, we add the exponents. So we multiplied exponential expressions, we add the exponents. Well, when we multiply within a logarithm, that can change to adding the logarithm of the first part plus the logarithm of the second part or factor. Similarly, we had division of exponents. When the bases are the same, you can actually just subtract the two exponents. If you take the logarithm of division, you end up subtracting the logarithms. And then the power rule, we have kind of wrote over this. We have x to the a, that whole expression to the b power, we know that we can multiply. Well, when we have an exponent of a, we can actually multiply the expression times that a. And that's the introduction to these. We're going to go ahead and prove each of these. So let's do that. So what we're going to do to start these proofs, we're going to go ahead and let log base b of x equal m and log base b of y equal n. And we're allowed to do this because log base b of x is just a number. Instead of saying log base b of x, we can call that m. Instead of log base b of y, it'll be some number n. Now, with those, we're going to go ahead and we're going to change their form. We're going to change each of those to exponential form. So let's do that. So we're going to change to exponential form. Just going to abbreviate there. And so if we change this to exponential form, we get b, the base, to the m is equal to x. And over here we get b to the n is equal to y. And what we do now is we just, we're going to take b to the m equals x, and we're going to multiply both sides by this equation. So we actually use the multiplication property of equality. And so if we take b to the m times b to the n, so I multiplied the left side by this, well, b to the n is the same thing as y, so I'm going to go ahead and multiply the right side by y. But these highlighted things are the same, so it's the same as we're multiplying both sides by the same value. Now what we're going to do is we're going to apply the exponential, the product rule for exponents. So the exponential product rule. So we have a power or an exponent times another exponent with the same base. We add the exponents, and that's equal to xy. And then what we're going to do is we're going to change back to log form. So changing to log form, log base b of xy equals m plus n. Well, that's, if I come up here, I'm going to highlight towards the top here. Here's log base b of x times y. It's telling us equals m plus n. Well, coming back up to our first row, what does m equal? And what does n equal? Well, m, we see, is equal to, so we have log base b of x times y You can put those in parentheses if you want to. M we see is equal to log base b of x, and n is equal to log base b of y. And we used our rules of exponents to prove this rule of logarithms, or our law of logarithms, the product rule. And we'll be using these rules later. These are just the proofs of them. So let's move on to the next one. We actually start off the exact same way. We are going to let log base b of x equal m, and log base b of y equal n. And then we're going to go ahead and work through this. So first we're going to change to exponential form. So you'll see that what I'm writing here in black is going to be very similar to what we wrote here in red. Change to exponential form. So this is b to the m is equal to x, and b to the n is equal to y. And now we're trying to prove the quotient rule, so we're going to divide. We're going to use the division property. It's really the multiplication property, but we're going to take this b to the m over b to the n. Well, that's going to be equal to x over y. Well, now we're going to use our our quotient property for exponential. So our exponential quotient property, and that is b to the m minus n equals x over y. We are now going to change back to log form. Well, that's going to be log base b of x over y equals m minus n, and you're seeing this is very much like our last one. M from above is equal to log base b of x. So log base b of x over y equals m, which is log base b of x, minus log base b of y. And there is our quotient rule. Those two are very much alike. For our last one, our power rule, we don't need two things. We're just going to let log base b of x equal m. We're going to change the form, and this is going to be, so we're going to change to log form, which gives us b to the m equals x. And now what we're going to do is we're just going to raise both sides to the a power. And so now we can use our power rule for exponents. Power rule, we have b to the a times m, as a power to a power you multiply, equals x to the a. We're going to change back to log form. Now we have to be careful here because we actually have two exponentials, and so we're going to think of this b as our base. So log base b of x to the a equals a times m. Hey, but what does m equal? Well, from our very beginning, we said we let m equal log base b of x. And so we get our final rule here, log base b of x to the a equals a times log base b of x. And there is the power rule for logarithms. So those are our three rules that we'll be using quite often. So make sure you know those. Make sure you can convert between the two forms. We'll learn one more property towards the end of this lesson here,